Good afternoon, everyone. This is Mike O'Malley here with a severe weather outlook and discussion for March 20th, 2022, recorded around 2:30 p.m. Eastern Time. We have a lot to talk about today, including the potential for a multi-day severe weather event across portions of the Gulf Coast and Southeast United States. So let's go ahead and jump straight into everything, taking a look at the Day 2 Convective Outlook from the Storm Prediction Center. We have an enhanced risk for severe storms, mainly across portions of central and southeast Texas, including Houston, Austin, Waco, and a slight risk from Dallas and Fort Worth through Arlington and Plano, and a marginal surrounding that through Oklahoma City and Norman, Oklahoma. So tomorrow's main risk is going to be the threat for isolated, strong tornadoes and the threat for wind and damaging hail. And we'll take a look at it in more detail in the model forecast here in a minute. We have this risk for severe storms tomorrow, and I honestly would not be surprised to see a couple of very intense tornadoes down here tracking along in this 10% region. We could even see maybe this get upgraded to a moderate risk, depending on the environment and how that decides to kind of cooperate tomorrow. But by far, the biggest risk is going to be the damaging wind and large hail threat with any of these supercells that develop tomorrow. And of course, those supercells are also capable of producing strong to violent tornadoes. And that same risk continues into day 3, or on Tuesday. We have a moderate risk from Baton Rouge, Louisiana, through Jackson, Mississippi, Hattiesburg, Clinton, and Pearl, Mississippi, with an enhanced risk through New Orleans, LaPlace, Tuscaloosa, Alabama, Gulfport, Mississippi, and a slight risk all the way from Lake Charles and Port Arthur through Mobile and Montgomery, Alabama, and a marginal risk surrounding that. The main primary concern, according to the Storm Prediction Center, for this day 3 moderate is the threat for strong to violent tornadoes once again. Again, this is a 45 hatched area. However, we're going to kind of dive into why tornadoes might not be the most favored mode, and supercells may not be the most favored mode for severe convection on Tuesday. We'll take a look at that here in the model forecast right now. So this is the NAM 3 kilometer. This is the high resolution NAM. This is the 12Z run valid. This will move this up to 8 p.m. this evening. So not much is going on right now, and that is certainly a good thing at the moment. So for right now, nothing is going on. We should, however, take a look at some of the observed soundings, and this is going to kind of pave way for what's going on for the severe weather threat over the next few days. So looking at Brownsville today, this is the 12Z observed sounding from Brownsville. Again, we don't really have a lot of moisture in the lowest levels, although there is a plume up here to just about 1 kilometer before it tapers off. And then there is more moisture up here from about 3 kilometers upwards to about 5 kilometers. So there is some moisture here. And this moisture is going to basically advect northward as we go and progress throughout the next few hours into the day tomorrow. This moisture will begin to increase and advect northward. And we can already see here in Lake Charles, again, that we're pretty dry in the low and mid levels, but we do have a lot more of this upper air moisture. So there actually might be some passing cirrus way up here, about 9 to 12 kilometers above ground level there. But again, we're really going to have to watch this moisture axis as it begins to move northward, and that's what's forecast. If we take a look here at the dew point, so we notice that right now, we'll move this up to about the current time. Air mass modification is already ongoing. This morning we started with dew points that were well down into the 30s and 40s. Now we've seen those dew points advect into the 50s, and along the immediate coast we have these dew points now approaching 60. And if we kind of take a representative sounding down there closer to Brownsville at this time, we can actually see that the sounding is a lot different from what we saw this morning. Again, we can kind of go back and reference the Brownsville sounding here. Brownsville sounding this morning, not a lot of moisture in the lowest levels, a little bit more moisture in the upper levels. We've actually completely almost reversed that. We have a lot of moisture now sitting down here in the low levels, and we've definitely been able to manage to dry out some of the mid-levels, so kind of setting up that elevated mix layer. And some of that actually is coming from the upper level, kind of the mid and upper levels here down here in Mexico, coming off the Mexican plateau. We notice that there's a very dry mid-level air mass here. And as this begins to surge northward, again, what's happening is we're transporting the lapse rates that are over here. There actually is some pretty steep 3 to 6 above ground level ascent going on here, or lapse rates rather. And those lapse rates are going to be transported basically among here. So we'll start to see those lapse rates change with time. And we can start to see here that as we head in through the day today and later this afternoon, we do steepen those lapse rates in the mid-levels up quite substantially. And again, we continue to moisten these low levels here. So that's very good if we want storm development, and definitely moisture to increase as the afternoon progresses tomorrow. We can see there's this very good air mass modification going on in Brownsville right now. And this isn't making it far northward because we don't have any true warm air advection surging northward at this point. We don't have that moisture advection surging northward at this time. However, we can start to see that that actually begins to change as we get deepening here. And as we get a surface response, we do start to pull those dew points northward. And by late tomorrow, we begin to see these dew points surge into the upper 60s across portions of central and southeastern Texas. And taking a sounding tomorrow, this is 22Z, I mean, we have an almost really perfect sounding here. We have some very good low-level moisture. It definitely will be cloudy though, and this is going to be a problem if we want significant destabilization in the atmosphere. So this is definitely suggesting more of a stratostack up here, and this could really hinder the severe weather potential for there. However, we do have this mixing ongoing, and this is still at 22Z, and with there being a really strong shear here from the 0 to 1 kilometer layer, we actually do have a lot of mixing that will be ongoing, and we can kind of see how the atmosphere is going to respond to that. We do start to erode that that capping there, and we begin to really allow for the storms to form, and there really is not at that point much in the way of capping here once we get past about 22Z. So the capping inversion will break and we get storms to develop. We can kind of take a look at that here in the reflectivity simulation. Again, those storms kind of erupt right there. You can see how they do develop, but these storms mainly here are not necessarily rooted at the surface, or they might be very shallow because we do have that capping inversion, and eventually it begins to break and we do get more of those surface-based storms that are rooted down there in the boundary layer. And this is definitely a bit more supportive for the idea of tornadoes tomorrow. And even going into late tomorrow night, into the overnight hours on Thursday, we can see more convection breaking out. And this is really when we'll have to watch for those isolated discrete supercells to form, and could put down a couple of significant tornadoes tomorrow. So again, if we look at the lapse rates right now, they're not all that impressive, but look where they are impressive out here across parts of the Mexican plateau and over portions of New Mexico and extreme western Texas. Those lapse rates from the Mexican plateau, those will move over into portions of Texas tomorrow. And that is what we were talking about, those lapse rates. It's very important to look at the source region for these lapse rates, and we can tell these lapse rates are originating down here in the Mexican Plateau region and translating over into Texas. And that is accompanied with an increase in the low-level flow and strong moisture return by tomorrow. So we could be talking about the potential for some pretty significant severe weather going into tomorrow night and into Tuesday morning. And again, the instability basically is responding. Again, we don't have much instability throughout most of the early afternoon, but a really sharp ramp up in that as we steepen the low level lapse rates, in the atmosphere here in the mid and upper levels, we really start to increase that convective available potential energy. And at the very same time, the convective inhibition, we can see that there's very strong capping throughout tomorrow, and that capping inversion weakens, and there's this little hole in through here where the convective inhibition is significantly weak for those surface-based storms to develop, and they could definitely move with, because the convective inhibition is weakening with time for the most part, and this might allow for some of that to produce a few significant tornadoes. Again, our storm relative helicity values are more than sufficient tomorrow for rotating updrafts and supporting those rotating storms. Again, we'll take a sounding here at 0Z across portions of eastern Texas, and we can tell that, again, this has a marginal tornado threat here, but aside from all the wonky stuff going on here, we notice that there's a very favorable hodograph, and there's actually some pretty good streamwise vorticity here. Again, this would be basically perpendicular, so there's definitely streamwise vorticity going on here in the lowest levels, and this is very important if we want a more efficient way of being able to convert the horizontal vorticity into vertical vorticity, and that will enable storms to rotate for longer amounts of time and potentially produce those significant tornadoes. Now, that's just one particular model, the 12Z HRRR. We can kind of take a look at that. We can tell here that on the HRRR, again, we have a little bit of a more favorable sounding for these discrete supercells to fire. One of the main problems here, if we actually take a look here at a sounding, one of the main problems is that we have a largely parallel wind flow from 1 to 6 kilometers. We can see here the 1 to 6 kilometer wind barbs. This is kind of important because this determines storm mode, and this is going to tie now into Tuesday's event across that moderate risk area, which we'll talk about here in a minute. But for determining storm mode, you really want to see your 6 kilometer wind here being more like this at a perpendicular angle rather than almost a parallel angle. These two lines are nearly parallel to each other. And because of that, when you get a shear vector orientation that is parallel to the boundary layer, you essentially have storms that are going to just basically ride the boundary, and storms that will basically just get entrained into another, and you have constant cell mergers going on. And that is a way to get a good amount of outflow and cold pull generation. And that's kind of what you see out here, is that this is not this is not one of those, discrete supercell looks. This is a multi-cell squalor, or kind of this, multi-cell or, QLCS event. And we don't really have much in the way of discrete supercells. And even if discrete supercells do form initially, the main threat going into Tuesday, early morning Tuesday, is going to be the damaging straight line wind threat for sure. There might be some supercells that end up developing down here as the squall line, maybe according to her, kind of weakens. You may get new initiation down to the south of that, and you might get discrete supercells for a little while. However, those eventually develop into a line. You can kind of see there is discrete elements here at 5Z, so this is at midnight on Tuesday. However, again, most of this is going to quickly grow upscale. There's not a lot that is going into the favorableness for this to just remain a mostly discrete mode throughout the evening. So this will likely transition into a squall line at some point. And this is reflected then going into the day on Tuesday. And if we take a look here at the 3 kilometer NAM, again, now we're going to be shifting gear to this moderate risk over here across portions of Louisiana and Mississippi. So this is for the day on Tuesday. We can see again that most of this, once again, is linear. And the Storm Prediction Center, and I've seen a bunch of people kind of say, well, there might be this high risk talk, or, the talk of these very long track tornadoes. Well, for that, let's take a look at some of the soundings here. So this is the New Orleans sounding here from the NAM 3 kilometer at 18Z, and transposed in the purple is the Lake Charles sounding also from the NAM 3 kilometer at also 18Z. And so we're taking a look here at a few things. Again, this is mainly right now we're looking at the parameters from the New Orleans sounding. Again, we see the New Orleans sounding pretty good moisture, and that moisture is available through really most of the mid-levels here, and then we start to dry out here. So definitely that elevated, sort of this elevated mixing layer here. And it is a little bit drier, or mainly a lot drier in the mid-levels than at Lake Charles. Lake Charles, you can see in the purple, is much more moist in the mid-levels here, and actually has this saturated level here near 100% saturation at about 18,000 feet or 500 millibars. And then it kind of tapers off before nearing saturation again up there just about 250 kilometers or so, or I'm sorry, 350. And so this is not necessarily the best for severe weather from the Jackson, Mississippi, or the, I'm sorry, not the Jackson, Mississippi, the Lake Charles, Louisiana sounding. However, again, this is now New Orleans that we're looking at. And New Orleans does have a very favorable curved photograph in the low levels. And if we actually look here from a storm relative perspective, we can see here that, again, in the purple, this is the Lake Charles sounding. And the one here in the normal colors that you're all familiar with, this is looking at the New Orleans sounding. So, again, for the most part, we have a very curved photograph, but look, we have still that 1 to 6 kilometer wind. It is a little bit more veered here, but we have southerly over southwesterly. And again, this is mainly still parallel to the overall flow. And you're just not going to get a lot in the way of, discrete elements with this type of, profile here. And one of the other things is that there is a little bit of convective inhibition here. You can kind of see that inferred virtual temperature, that there is just a little bit of convective inhibition, so it might take just a little bit more forcing to get any thunderstorms to develop. And in fact here, that's kind of what happens, is that we notice that we don't really get any warm sector supercells to actually form. They're all kind of out here, if you want to call these supercells, and we'll take the sounding here at 22Z on Tuesday. And again, this isn't the most favorable I've seen for tornadoes. Doesn't mean you can't get tornadoes out of this. I mean, there is definitely some curvature in the lowest 1 kilometer. And above that, there is some decent upper level venting. So not the worst. But also at the same time, you end up with a little bit more of a capping inversion here. It's a little bit more capped in the atmosphere and a little bit more moist up here in the the mid and upper levels. And also, once again, your shear vectors in the lowest 1 to 6 kilometers here are largely, this is even more parallel. So this favors rapid upscale growth, and I just do not see there being this massive, discrete supercellular threat ahead of the main line. And this is even echoed in some of the HER soundings as well. And we can even see here on the HRRR, this only goes out to 12Z Tuesday, but you just don't see discrete elements there. And taking a HER sounding near New Orleans, again, your shear vectors are still largely parallel for the most part. Very great shear, though, in the lowest 3 kilometers, over 200 to 300 meters squared per second squared of shear, and certainly effective inflow layer has a lot of shear in it, so these storms can take advantage of that. But again, mainly looking at your storm motion here, a right mover, 33 knots, generally off towards the north and east, and you generally would be intersecting with other storms, and we don't expect to see supercells forming out here at 12Z on Tuesday anyway. But this just does not look like a significant tornado threat as of right now. We could take a look here at some of the other models. We'll take a look here at the RAP instance here. I believe that they have one that goes out to 51 hours. There we go. So this is the RAP, and the RAP is mainly suggesting the same, maybe a little bit more convection in the open warm sector. on Tuesday morning, and that might also put a little bit of a hindrance on the instability and potential for any significant tornadoes there. Here in the RAP sounding, you have a pretty steep low-level lapse rate, and there is a modest mid-level lapse rate as well. That's definitely a modest mid-level lapse rate. There's not a lot of dry air. There's actually some pretty significant moisture up here. And this is one of the things that, again, you got a lot of cloud cover up and through this layer. So it definitely limits the amount of instability that's automatically coming down. And with this, with the temperature dew point spread, your LCLs are up above or right near about 1,000 meters. So definitely getting on the upper end of when we would expect to see SIGTORs, because you don't really get any SIGTORs with LCLs, your lifted condensation level, or the base of the storm clouds over 1,000 meters. You just don't really get that. You could still get some, weaker landspout-ish tornadoes, but with, LCLs approaching 1,000 meters, I would not expect to see SIGTORs in an environment that way. And again, this could also change. I mean, this is still 3 days out. The bulk shear is pretty low too. I mean, it's only contributing 47 knots here on the RAP sounding. So 47 knots of effective bulk shear. It's definitely on the lower end, although it's still there. I mean, bulk shear values in the 40s definitely do support supercells, but this would be on the lower end of that spectrum. So just kind of some ideas and thoughts on what might be happening. Either way, there seems to be a pretty significant wind threat that is going to be associated with this. This is then 18Z on the RAP forecast. Definitely showing a very potent squall line. So, and don't get me wrong, there could still be some embedded supercell structures in the squall line, and that could also produce some significant tornadoes. Just because you get a squall line does not mean you cannot get significant tornadoes. So that's going to be one thing to watch. All right. That being said, I hope you all have a great rest of your afternoon and evening. Of course, this is Michael O'Malley, and I'll talk to you guys later.